All right, so it looks like we're live. It's very exciting. First ever live stream here on the Game of Knowing. If you're watching, thanks for watching. Don't think anybody's here quite yet, so we'll just kind of hang out for a moment. I haven't posted about this or anything yet, so if you're subscribed, you're one of the lucky few. Tonight we're going to be working on kind of a neat project. Some of you may have seen this before. I've posted about it on Twitter a little bit, and it's sort of been out there in the DIY electronics community. But this little guy is Baby Noodle Feet. One sec, let me just click over to another window so I can see what you're seeing. This little guy is called Baby Noodle Feet, and it's part of an art project by this really awesome roboticist and artist named Sarah Petkis, and she is working on a much larger version of this robot. Probably about 15 times the size. That's mechatronic and all sorts of things. But she has made this little mini version that's 3D printable, and she sells these neat little brain boards for it. So if we just kind of let him sit here for a second, you'll see he's got these two little LED eyes and 4 legs. I 3D printed and assembled this myself, so it's kind of neat. So he beeps, he blinks, and it's all just driven by a very small little itty tiny microcontroller. I forget the exact micro, but there's a little piezo on there. It's totally coin cell driven, very cute, and sort of atmospheric. And so I've named this one, so the project overall is called Noodle Feet, and these are Baby Noodle Feet. So I've named this one Rigatoni, or Tony for short, and I think he's just about the cutest little thing. So he can just kind of sit there and hang out. He's just blinking out. It's just, maybe he's a little bit camera shy, so I'm just going to keep him over here. But the reason that we're having the stream tonight is you saw the little brain board on there that has the eyes and the piezo element, and that just actually kind of came out a couple weeks ago. I ordered it from Sarah Petkis, and she sent it. I installed it in my Baby Noodle Feet. But before that came out, I ordered some components to make a brain board of my own. I had printed out Rigatoni here, just this little skeleton, and it was just that, just a skeleton. And so I wanted to be able to sort of, create my own behaviors for it. Maybe some interaction and those sort of things. So that's what we're going to be working on tonight. You can see I have a few components here. So we're essentially just going to be making a brain board for another Baby Noodle Feet, or Noodle Spawnling, if you will. Don't worry, we're not going to be performing a live lobotomy here. Rigatoni is done. He's very cute and perfect just as he is. Thank you very much. So I actually have another set of sort of the skeleton 3D printed parts that I printed out a few days ago. And so maybe in the stream, maybe in another stream, we're going to be installing the brain board that we make here into another Baby Noodle Feet, and we'll get to see another one of these cute little guys come to life with some unique behaviors. But with that being said, let's sort of dive right in. So just a little bit of background. So the whole idea behind Sarah Petkis's Noodle Feet project is creating a really interactive robot that has a little bit less objective goals than most of the robots that we see today. Usually when you have a robot, it's supposed to do something. It's kind of like an appliance. It's supposed to, maybe if it's an exploration robot like the Curiosity rover, it's supposed to go someplace and take really objective measurements and, follow orders to a T, and, collect numbers and send back data. And even if it's something that's, maybe in your home, like an Amazon Alexa or something like that, those are a little bit more free-form robots and interactions that we have with them. But at the end of the day, they're robots that are around to perform a very specific task. Really not all that much different than something like, a washing machine where you press a button and it does what you tell it to do. Noodle, and by extension the little Baby Noodle Feet, are a little bit different. So the whole idea is creating robots that explore and relate to the world much like we as humans, and especially like a child would. So, whereas we have, Curiosity that goes to Mars and goes along very predetermined routes, and it's awesome. But if Noodle were to go to Mars, he might jump around or want to taste things. And so that's sort of a big part of the lore of this project and this character that Sarah Petkus has created, which I think is really awesome. So creating a robot that's not so much a tool for exploration, but a robot that explores itself and wants to touch and get involved with things and play around, and sort of has its own spirit. So for this project, I wanted to make sure that, I'm going to be creating my own brain board here on the stream, but I wanted to make sure that that same sort of spirit stays with whatever it is that I create. It's still sort of fun and interactive and something that draws your attention. I feel like, this little guy, this baby Noodle feet, that's, sort of the canonical version, if you will, does that really well. If you walk into a room and he's there, you see him blinking at you, and there's a real sort of likeness to it, even with the very few behaviors that it has. So I really wanted to do my best to maintain that. So the parts that we have to try and accomplish that here tonight are, I'm starting out with an Adafruit Trinket M0, which is a little ARM M0 board. Just has, I think, like 4 or 5 GPIO pins, but it's actually pretty powerful. It runs quite fast, and it can run CircuitPython, which is what we're going to be using to program this tonight. It's kind of the first time I've used it. I've been playing around with it in the last couple days, just sort of preparing for this stream, but I'm excited to check that out. CircuitPython is just sort of Python for microcontrollers. So it allows for, to me at least, a little bit more creative coding, because you're not so focused with syntax and those sort of things. There's a lot less syntax, and the functions can be a lot more powerful than if you were doing something in C. And there are some really great libraries that folks at Adafruit and other people involved with the project have created that should enable us to do some pretty cool stuff. I'm not sure how far we're going to get just tonight, but hopefully that'll be neat. So there's our little Trinket M0. It's going to be sort of the brains of the brain operation, if you will. Now beyond that, first we're going to do a couple of things just sort of to replicate this baby Noodle feet's functions. So the first thing is, he's got to be able to see the world, right? So we have some eyes, and for these I'm just going to be using these tiny little, let's see, I might actually just try this on the other camera to see if we can get it to focus, but tiny little LED sequins. Nope, that's not happening. But yeah, it's basically just a little surface mount LED and a resistor. Should make it really easy for us to pose them and make sure that his eyes are looking in a reasonable direction and those sort of things when they're blinking and winking at us. So that's pretty neat. For the power, sort of his stomach, if you will, we have a little coin cell battery, a little coin cell holder. It's a small one. I think this is just like a 12mm coin cell battery. So power use is definitely going to be a consideration here. This is all 3 volt stuff, but want to make sure that we're not using too much power. We don't want to drain this battery too quickly. And then next, we have actually kind of one of two things. So I picked up, one of the things that this baby Noodle feet does that we already have, and that our new one will do, is be able to speak and make some cute little sounds. So we actually have 2 options for doing this. I got a speaker, which is, or just like a normal speaker that you might think of, and also a little piezoelectric element speaker. So I'm not totally sure which one of these we're going to use. I'm kind of leaning toward the piezo, largely for power considerations, and also for space, because as you can see, we're going to be using the same skeleton for the second baby Noodle feet that we build, and there's really not that much space. It's meant for this very integrated little, Sarah calls it a marshmallow board, for the brain board. And if we use the full speaker, we're going to need to use this amplifier as well, which is quite small and also pretty power efficient. But I'm not sure I want to do that, because it will draw a little bit more power than the piezo element. It'll take up a little bit more space, and it will also be a little bit more difficult to program. Not significantly so, but I'll need to be a little bit more thoughtful about the way that I'm creating the audio for it. So Real quickly, before we go into sort of laying out the circuit and those sort of things, I just want to lay out a few of sort of my goals with this. So what we're sort of shooting for, hopefully by the end of the stream, we will have with this assortment of components that we have here. And there's wire and other stuff off camera. Don't need to show right now, but we'll be seeing that in just a moment. So let's just sort of think about what we need Noodle to do. So the first thing that he needs to be able to do, forgot one more crucial component. So probably the biggest addition beyond the existing baby Noodle feet that we're going to have is some sort of interaction. So a big part of Noodle's lore is that he loves to taste things and interact with his environment. He's not just a passive robot. He's responding and really conscious of the things that are going on around him. And so to do that in a small form factor, I picked up this little vibration sensor. It actually looks a lot like a capacitor, but what's inside of there is a loose little spring coil. And so when you hit this, the spring coil inside makes contact with the external metal can and closes a circuit. So you see there's 2 pins here, and those will be closed when, say you flick it, or if Noodle is bumped or something like that. So that'll be kind of neat. That will enable us to have like some special behaviors that only happen when somebody's touching Noodle or if he's shaking around or something like that, which I think sort of adds a neat other dimension to him as well. It's not just sort of cute and sitting there, but also something that you can pick up and touch and will respond to you. Since we just talked about that, let's open up with, we need Noodle to be able to respond to input. Just write goals here. Okay, so goals, Noodle needs to be able to respond to input. He also needs to be able to, and how is this going to happen? Maybe we'll have a sound that he does when that little switch is triggered. We'll also maybe have a special light thing that happens when that switch is triggered, when that little vibration sensor is triggered. Let's see, what else? So after, when he's just sitting there, when he's just kind of hanging out, nobody's interacting with him, we want Noodle to be able to, just sort of be looking around and hanging out. So we want a couple of eye behaviors. And for this, I think that Sarah really did a very good job on the original Marshmallow board. So there's sort of 4 different behaviors that Noodle does. One, he can just be sitting there with both lights on, which is what he's doing right now, as you can see. He can also blink, which means, both eyes at the same time, blink. He can wink on either side, so just left or just right. And then he can also sort of blink, you might say. So what he does is he'll blink one eye and then the other. So it looks like he's just blinking, but there's sort of a little bit of movement to it, which I think is kind of neat. And so those things I think I'm just going to replicate. So eye behaviors, we have a on, we have a blink, we have a wink, and that's right blink and left blink. Okay, we have a and then finally we have blink, but directional. So first the right, then left, and then the left, then right. Okay, so that's pretty simple. So those are just sort of the eye behaviors he's going to be doing. Those are the most common things that he does, that Noodle will do. And then finally we have sounds. So you can probably hear every couple of seconds he's doing a little bit of beeping action. And I think that this Marshmallow, the sort of canonical Noodle, only really has one sound. It's sort of a little tritone beep. And I like it. It's fantastic and adds a lot to the character. But at the same time, this is something that I want to have on for like long periods of time. The battery lasts a while. And so I think it would be neat if I had a few different tones, especially with this Trinket M0. I actually have like a lot of memory in the microcontroller, so there's space to do a few different tone patterns and those sort of things. And so to sort of keep it fresh, enable him to say several different things. Maybe he can have a different tone pattern when he's shaken or that vibration sensor is triggered. You don't want it to become overly repetitive. So he can also do sounds. And I'm going to say let's do at least 3 sound patterns. And because we're probably just going to be using the piezoelectric element, it'll just be, pure tones. It won't be, a full song or anything like that. And even though this microcontroller does have a fair amount of memory, it doesn't really have enough to store like, a normal audio clip like part of a song or something. So this will have to do. And I think it'll still be pretty cool. Let's see. So those are sort of the behaviors, the outward behaviors. And then to control those things, we know that Noodle might do particular things when he's like shaken, but when he's just sitting around, we also want him to be, blinking and making sounds, as you can see he's doing over here. So we need some sort of an event loop to randomize those actions. So most of the time he's just going to be sitting there not making any sound, or not blinking or winking or anything like that. But we want to make sure that every few seconds, in this case it seems to be about every like 15 seconds, and we can stick with that and kind of play around with the frequency as well. But we want a pseudo-random behavior function that's going to make it so that in a rather organic fashion, every once in a while, Noodle will say something or blink or in some way make himself known, if you will. So random-ish event loop. And CircuitPython has some very simple, just like random number functions and those sort of things. And since this is not anything cryptographic, we can just use those. We don't need to worry about getting true or almost true random numbers. So that should be somewhat trivial. So now that we have our goals sort of written out here, I'm just going to move the components aside so we can still see them, and we'll just start to kind of draw out the circuit, just so that as I'm working through this and streaming at the same time, which by the way seems to be going pretty well. Hello, if you've joined since we started up. It looks like we have 1 person watching, so you're getting the best seats in the house for this one. Lucky you. I'll also probably record this and just post it on my channel later, so we have it for posterity. But yeah, so let's dive right into sort of a little bit of a circuit diagram. So at the heart of the operation, and forgive me, I am a pretty horrible artist, so we're gonna do our best. Just bear with me here if you can. At the heart of the operation, we have, this is just going to be our trinket. Okay, cool. So this has, we have 5 I/O pins on there. I think we're going to use 4, I believe. First of all, we're going to have, I'm not really going to draw out the circuit diagram, more of just like a block diagram, or a pseudo block diagram. So the one thing that I do want to make sure is that we have whatever is generating our sound on an analog pin. It's not necessarily essential because I think we can actually do PWM on most of these pins, but it'll give me a little bit more flexibility down the road if I want to do something with a speaker as opposed to the piezoelectric element or anything like that. So the analog pin on this is pin 1. So I'm just going to draw pin 1. It's going to go to audio. And again, that's probably just going to be our little piezo element. Let's see. In addition to that, we have 2 LEDs, and because we're going to be doing, blinking and winking and those sort of things, we want to have those each individually controlled. So, let's see. I think I'm just sort of looking at the orientation of the M0 here, and because those LEDs are going to be facing forward, and we also want the USB connector to be facing forward for reprogrammability, without having to, wiggle the whole board or the whole assembly out of Noodle Feet's head. Again, no lobotomies. I think I want to use the pins sort of closest to the front of the board. So I'm going to use pins 0 and 4 for the LED eyes. Okay, this is pin 0, eye. Okay, so I started out with circuit diagram, now we went to block diagram. This is, sort of an unmitigated disaster in some ways, but I think we should be able to get the idea across. And then I said pin 4 is going to be coming out to our other eye. Pin 4, cool. Okay. Now, again, just sort of thinking spatially about this circuit, because we're not using any sort of a prototyping board or anything like that. The next pin on this left side of the board is pin 3, digital pin 3. I'm going to use that for our vibration sensor, because I'm going to need to, I think, just directly bridge the leads of this sensor between the pin that it's connected to, pin 3, and the ground pin. I don't want to have to be using wires for this, and the leads are long enough that I can do that, but only if I use pin 3, which is just right here. And I'll make sure to keep the leads on the eye, which is going to pin 4, insulated, or keep the insulation right up to the pad that I'm going to be soldering to, so that we won't risk shorting the leads on the vibrations sensor with any of our other wires. So that should be good. So pin 3, that's going to be coming out to our vibration sensor. Cool. All right. So now we have our sound, we have our sensor, we have our speaker, we have, I think that's it in terms of digital I/O. Then the one other thing we need is our battery. So battery. Now, again, going back to sort of our spatial construction here, there's not that much space in Baby Noodle Feet's head area, skull, if you will, to put all this stuff. It's very closely integrated with surface mount packages and everything in the marshmallow brain board that Sarah Petkus created for it. So in order to still use this same space, I'm going to be sort of stacking the boards. So my plan is to have the Trinket be sort of in the middle, and then on top of that, almost like, I just kind of think of like BB-8's little antenna. This little, our vibration sensor will be poking up, like so, and then below that we're going to have the battery, and then eyes sort of facing forward, and the piezoelectric element stacked on top sort of as well. And I think the piezo element can be a little bit free-floating because there is quite a bit of space on the top of the skull that we can fit that into, and maybe tack it down with hot glue or something like that, so it's not just floating around, banging around in there, but that shouldn't be too much of an issue. And then the one concern that arises when we're stacking like that is shorting between the battery. We have this big metal battery holder on this board, and other wires and stuff, so I'm going to use some electrical tape to sort of insulate those 3 sandwich layers as necessary. So that shouldn't be too bad. Hopefully. We'll see how it goes. Don't want to jinx ourselves there. So, that being said, let's dive right in. We have a shockingly incomplete circuit diagram slash block diagram. We have all the components we need, and all right, I actually have my third hands tool kind of right here, so we can just sort of fold it down and into frame. One sec, I'm switching sort of between two different pieces of software here to make this work. All right. Get my soldering iron. I'm going to disappear from frame for just a moment so that I can plug this in. I just have a little pen style soldering iron, but good enough for me. Hey! All right. So we're heating up there. In the meantime, you can start to fixture our board. So just sort of the way that the stream is going to go from here, hopefully, is I'm planning to sort of assemble this in as small and compact of a form factor as I can right now, and then develop the software for it. And I also have some screen capture stuff, so I can show you sort of as I'm writing that code, playing around with the Circuit Python a little bit. But because this is something that's like really interactive, and again, sort of going back to the whole Noodle Feet project, it's about creating something that feels right as opposed to fulfills objective goals. So I want to have the hardware done when I'm writing the code, so that I can be, tweaking timings and those sort of things. It's not really something where I can, go in ahead of time and write the code and be like, okay, this is going to be perfect, and then just have it run on hardware. I need to sort of code with the hardware, if you will. So, I think I was talking about this vibration sensor, and I want to make sure that this gets into the right position. And the leads on this are also a little bit delicate. So, you know what I'm actually going to do? I have a silicone stranded wire that's like really flexible that I can use for the LEDs and those sort of things. So instead of using this pin 4 for the left eye, I'm going to use that pin 4 for the vibration sensor. I don't know how well you can see this. I probably need to get a new camera for the soldering stuff, but on this side of the board we have battery voltage, ground, pin 4, pin 3, reset. And so I want the vibration sensor to be able to go right into the ground and then right into its sensing pin. So I'm just going to use pin 4 for that, and then use pin 3 for the eye, because if I need to use a little bit of a longer wire lead for that left eye, that's totally fine. So I think that's what I'm going to do. Cool. So I think I'm just going to start by soldering this little guy in place. It's not a super sensitive component. It's literally just a little spring in there, which I think is pretty rad. And I want to keep the leads long-ish, because I feel like having a little something poking up off the top of it sort of adds to the character a little bit. It's sort of cute. And also, it'll make it a little bit easier for this thing to trigger. I don't want you to really have to shake Noodle a whole ton to get him to respond. It should be relatively easy. So, I have this really nice third hands tool, but it's sort of actually hard to get stuff into the right position most of the time. I still haven't really found one that's great, and it seems like jeweler's tools seem to be the best, but those are generally pretty expensive. Okay. Looks pretty good. So, well, yeah, this solder cam is not great. Is that going to focus? I can try and just move the whole thing down a little bit. because it was able to focus on the paper pretty well. I think this might just be a little bit too close in for this camera's liking. Basically just a fake GoPro. I don't know. Let me try killing this light real quick. No, that doesn't help. It's a focus issue, not an exposure issue. Okay. So, note to future self, get some sort of like a microscope or something that I can use to actually record this in a reasonable manner. When I was sort of doing a couple of little test recordings for this, I was just, looking at stuff like this paper that was flat on the desk and did not look at actually soldering with this camera, or filming soldering with this camera. So a little bit different, we find out. Wow, okay. I'll be right back. Just lost our component. Thank goodness. Okay, that would have been a really unfortunate way to end the stream. Lost a vibration sensor. Okay, there we go. So you probably cannot see this, but we've now gotten the leads for the vibration sensor through the correct holes there. Knowing that this is not the best footage, I will do my best to sort of get through this rather quickly. And if y'all have any, see, is there anyone watching right now? Okay, we apparently still have one viewer, which is pretty dope. So whoever you are, thank you. If you have any questions or anything you'd like me to talk about or anything like that, let me know in the chat, because I have that open in the stream window, as you might be able to see. So, soldering iron's oxidized a little bit while it was just sitting there. Okay. Okay, so there's our little vibration sensor tacked down. Looking good. It's pretty easy. Just hold it up so you can see here. And as you can see, I've left a little bit of lead. It is intentional. That's A, going to give me space to solder in other stuff, but more importantly, I think it's going to look kind of cute sticking up almost like a little antenna, and make it easier for this thing to be triggered, this sensor to be triggered. So that's now between pin 4 and ground. I'm going to take my little flesh cutters and just trim that down. Ooh. Get that on camera. All right, so that's now trimmed. Next, I think I'm going to do the LEDs next, because those sort of need to be posed a little bit. So I want to make sure that I'm not sort of blocking my angles with the soldering iron and those sort of things with other components before I get those in. So, sort of thinking of how to do this. We could do a common ground connection, which is probably the way to go. The really nice thing about these LED sequence, and the reason I went with them, is that they have built-in resistors, so I don't need to worry about 4 components. It's just 2. So I'm thinking, ooh, maybe we go vertical. Huh. If there is anybody in the chat, this would be a good time to weigh in, because I'm not entirely sure. So we could do like a vertical orientation there, so we'd have 2 little eyes looking out like this, like that, or we could do horizontal. I had originally been planning on horizontal, and I think I'm probably going to stick with that. Probably. So, yeah, let's just go with that. Let's go horizontal. Got some solid core wire here that I'm going to use just for this part, because it'll make these eyes posable, as opposed to a silicone stranded core, which will be flexible, a little bit easier to work with in this case, but will also mean that I can't pose them because it just flops all around. Okay, gonna strip our wire here. So this needs to be like way shorter. Okay, I'm just gonna cut it in half, I guess. So what I'm thinking right now is solid core wire to positive on both LEDs, and I'll position them so that the positive lead or pad is on the outside on both sides, and then I can have a common ground connection in the center with a third piece of wire that can then be brought back to our ground connection on the board. I think that's probably the way to go, as opposed to having kind of 2 separate loops. And I'm going to leave a little bit of excess wire on both of these so that it can be, posed and folded or whatever. All right. So we're going from pin 0 to 1 LED, and from pin 3 to the other LED. Because remember, we switched these on the left side for the vibration sensor. Cool. Just to get this first one, I think I might just use the... Oh no, we want positive. Just going to kind of balance it there, and then I can cut down the lead in just a moment. Ooh. Don't want to melt our... Yeah, we're kind of on camera, debatably. Don't want to melt our insulation too much here. Okay. Also don't want to melt our hands. All right. Here we go. Now if I just sort of remelt the solder, I think the component, and I can hold this. Just trying to kind of navigate around a camera for the first time. Kind of fun. Okay, just wait for the solder to set there. Good. I would normally use a tweezer for that, but left it at my work, unfortunately. This tweezer I normally use for surface mount stuff. So we now have a very handsome little half soldered LED sequin. Very nice. This wire is pretty cheap, so we melted the insulation a little bit farther down. Do we need that insulation is the question. Probably not, actually. Yeah, probably not. So I'll just cut this down a little bit more and strip it. Okay, cool. Okay, I actually like that place for the LED, sort of leaning on the USB connector a little bit. And I don't mean it's not, you know, really protruding so far out of baby Noodle's face, because I think it would be a little bit ridiculous if we had it all the way out here, the LED like all the way out here. So now we'll try very carefully to solder this in without it falling out. I was watching an electronic stream by Micah Scott. I don't know if any of you know her the other day, but she uses a little bit of like blue tack on the bottom of boards to hold in components when she's soldering like this. I think that's a pretty common technique, but I hadn't thought of that before, and so I think I might need to pick some of that up, because it seems like half the time when I'm trying to do this, most of the problem is just fixturing the components when I'm trying to solder them in. All right, beautiful. Well, not too much trouble fixturing the components this time. That's always nice. Cool, so there's one. Very nice. And now you can sort of see, oh, he's gonna have like a little mouth. That's really cute. Okay, so, okay, I actually really like this, and I'm glad we went with the horizontal orientation as opposed to the vertical, so here we go. Let's see if this will focus. Please focus. It did it. Ah! Come on. Yeah, there you go. That's it. That's what you want to see. Look at it. Very cute. Awesome. So here's our little one-eyed half baby Noodle. Sorry if I'm taking too much joy in every step of this. It's just really cute to finally see this coming together. I've been planning this out for a little while, so we need to actually see it. Now we can do our second little LED sequence, or sequin rather, singular. All right. Again, going to positive. For the outer contact, so we can have that common ground in the middle. These things are tiny. Adafruit sells these, I think, like specifically for wearables, and it's easy to see these would be really great for that, because the big thing with wearables, especially when you're sewing to fabric, is not sort of disrupting the flow of the material. You know, so it's still comfortable to wear. And these are just so tiny. It's like having a little rhinestone on an Ed Hardy shirt or something like that. Not that I would know, of course. All right. Oh, no, lifted up that wire, lifted up the component a little bit on the wire so it's not totally down against the insulation. Okay. There we go. Very nice. Cool, okay. Good enough for me. I can just trim this. Looking good. And we want to get Okay, I'm glad I left this one a little bit longer because remember I kind of forgot, we need to now get around this vibration sensor to get it all the way out to here. So I think I actually have just about the perfect, so I don't know where I was in the frame, but we need to get this kind of around the vibration sensor to get the LED sequence out to here so it can be level with the other one. And I guess we actually, okay, so as you can see on this one, the one we already installed, the resistor is on top, whereas because this one's coming from the other side, the LED will be on top and the resistor on the bottom. It's a little funky. Is it worth doing? So now our ground wire will be a little more complicated, and we also risk shorting with those center contacts. But it also looks a bit better. I would say, like, this is kind of goofy to have these eyes off level, and it's very slight, but this whole thing is small enough that it's pretty noticeable, I would say. Hopefully y'all see what I'm talking about. So just like when we have this like so, the screen right LED is just a little bit above the left one. A little bit goofy. So I think I am actually going to go this way around. Make sure to keep some distance between those center contacts so that we're not shorting out our positive and negative connections there. And then our ground wire will just be a little bit longer, going from this left one, or the right side of this left one, over to the right side of this right one, to there. Sort of a bummer, but I think that's probably the best option. Gonna strip down a little bit there. Awesome. So this is kind of going to be our look. Might have a little bit much wire there, so I'm just going to give it a little bend. And there we have it. Still goofy, but better, I think. It's supposed to be goofy. I mean, it's a baby robot named Baby Noodle Feet. Like, it's pretty rad. Okay, there we go. It's kind of derpy, I have to admit. A little bit derpy, but I'm here for it. So, and again, making sure we don't have anything shorting there. We don't, we're all good. Okay, perfect. Fixtured and ready to go. All right, LED sequence number 2 is in, or halfway in, that is. There we go. Pretty cool. All right, and mentioned a little while ago, sort of, making sure that we're not shorting anything out. I might just put a little bit of electrical tape on top of that USB connector when we're done to make sure that we're not shorting between these pads and the connector, because I think the exterior of these connectors is tied to ground, which, at least on this side, is not what we want. Yeah, I'm not going to solder to that or use that ground, but I think that's what it's tied to. Okay, sweet. So we've got those, and now we just sort of need, there we go, making sure we're staying in the middle of the frame. Now we just sort of need almost like a little glasses bridge between over here and over here for our ground connection. So I will cut a little wire for that. And this one, I think I'm probably just going to strip all the way, question mark. I think that's probably the way to go, because then I'm going to need to solder to it almost like a Y splitter, to go from this little wire to ground on the board. So I'm just going to strip a little bit in the end, and then because this is so short, I can just pull out the insulation like so. I think we can probably even trim that down a little more, and then bend in some right angles. All right. Drop that again. There we go. Okay. So here's our little... it's all over the place. Okay. So here's our little connector. Little glasses bridge, if you will. Nose bridge. Here we go. There's one side. I think it's a good length. There we go. Yep, and we're in. Okay, so now you can see. So this, wasn't really thinking about this, but this does sort of fix the distance between the eyes. And I think that's good. That's kind of what it was before we installed this as well. So we have our two little LED sequin eyes and our little USB mouth. So I'm just going to solder that ground connection in between the two ground pads on the LED sequins. Cool. Very nice. All right. Trim the leads a little bit. Okay. So, there we go. There is our little baby noodle feet face. What do you think? What do you think, Rigatoni? I'll have him look. He looks distinctly unimpressed. It's okay. You'll like him when he's all done. Also, perhaps a little bit disturbing to watch what is effectively your species version of brain surgery right in front of you. So I understand, but it's all going to be all right, I promise. But I think this is actually coming along pretty well. So now we just need to go from this, this wire we just installed to ground on the board. Because there is actually only one ground pin or like header hole, I'm going to be sort of soldering to the leg of the vibration sensor. But that's okay. It's not a very temperature sensitive component. All right. So we do want to, like, our one sort of hazard here is that we have that ground wire relatively close to this left positive or power wire for this sequence. So we don't want to melt through the positive wire and cause a short between those two. So we do want to be a little bit careful of just sort of where we're putting pressure and where we're applying heat when we make this last LED sequin connection here. This one I think I'll probably also just strip all the way because it's so short. There's another little length of solid core wire. Check back in. Still one person watching. It may be me. I'm not entirely sure. If you're watching, just drop something in the chat. I'd love to know who you are. if it's me, like, I guess I do know who you are. Tragic. So let's strip down this little piece. Make sure we're on screen. There we go. And this one is real short. It's actually going to be kind of hard to solder in just because it's so minuscule here. I'm not even going to try to use the helping hands tool here. So I think what maybe I will. So I think what I might do is just sort of tin the wire and then bring it in. It won't pick up much solder because it's just a single piece of solid core 22 gauge wire, but it'll hopefully pick up enough to be able to just tack it down to that other one. Come on. Take the solder. There we go. Okay, cool. Very nice. Whew. Then we can just connect this is a tiny piece of wire. Okay. I'm just going to connect over here at this little joint. Nope. All right. We'll get it. All right, it's in there, as you can see, very precariously. Now, I'm just going to rotate my grip on the piece a little bit so that you can see and so that I can see. So I need to cut the wire down a little bit, and we're just going to the now left lead of this vibration sensor package. Just going to bend the wire a little bit. Got it. Okay. Now we're home free. And I apologize because this is really just not going to be visible, I guess, at this point. Okay, so I'm just going to solder that ground wire real quick. Oh no. So just bridge the legs. Damn. Grab my solder sucker real quick. Hopefully we'll be able to get this out. Got it. So, yeah, I think we're good. Sweet. Okay, so I'll hold this up to the main webcam so hopefully we can get a little bit of a view of it. But there's, I think, our eyes and vibration sensor installed. Hopefully we can get this thing to focus again. There we go. Sweet. Okay. So there's a vibration sensor. You can see the eyes and the wiring there. Yeah. You can sort of see this one little silver wire there. Not actually silver, but silver in color, going from the LED sequence at screen left to one of the legs of the vibration sensor, which is tied to ground. Cool. And again, there it is from the front. Very cute. Very neat. All right. So with that out of the way, I guess next we'll do the piezo, and then just the battery holder. It's actually going pretty well, isn't it? So the piezo, remember we wanted to do that to pin 1 because that's our analog pin. Not sure that's actually going to make any difference, but why not? We're not using it anyway. So I'm going to trim down these rather long leads that it came with quite a bit. Going to leave a little bit of slack, one because I want to be able to sort of position this element within the head, and also because this insulation on these wires is ridiculously cheap. So if it does melt or whatever happens, I want to have a little bit of slack for myself to be able to, restrip and try this again. Cool. So there we have red and black. We're going to do red into this little hole. This is like 30 gauge wire, so I'm going to need to hold both components with the helping hands tool simply because even the insulation can fit right through the little 0.1 inch header holes on the board. All right. I sincerely hope that at some point within my lifetime, and better yet within my career, somebody comes up with a helping hand or third hand tool that actually just keeps stuff where you want it, because it's so tough to position pieces. Okay, perfect. So there's one wire. Again, I apologize for the focus on this, folks. There's one wire of our piezo, and this ground connection over here on this other side is getting a little bit crowded, so we want to be careful not to mess up any of the connections I just did. We're going to be going back to that same lead of the vibration sensor. I guess I could actually just solder to this silver wire. That might be the way to go. All right. So you can hopefully kind of see, have our little black wire here, in contact with that silver wire. So we've kind of just created a ground rail, really. All right. You may have seen there was a little bit of movement. I think we melted one of the other solder joints by doing that, but it reset and we're all good. I'll go back through this with my multimeter once we sort of have everything assembled to make sure that we actually have continuity between the things we need continuity between. But I think for the moment it should be okay. I've been going for about an hour, so almost done with the hardware, so that's pretty great. I would really just have to add the battery holder. This isn't super complicated, but we're making good progress. And it's tiny. Okay, so the battery holder, there are a couple different ways we could do this. I guess just this sort of orientation is probably the way to go, given the fact that we're going to have electrical tape all over this thing, so there will be no danger of it shorting out. Yeah, I guess that's probably the right orientation, because then, you know, then this thing is very compact. Tall, a little bit taller than the original marshmallow board, but very compact. Cool. I think I'm going to do it with the battery holder down, just so that we have a little bit less stuff to cover with electrical tape. And I also don't want to have to, you know, undo any electrical tape whenever I want to replace the battery, which I will have to do, I think, fairly frequently for this. So if we can just have the tape on the contacts and on the contacts on the bottom of the board here, that's much better than on the top with the battery holder itself. So I also think I want this free floating, or a little bit more free floating, as opposed to locked into position like we have with these solid core wires on these components. So I'm going to grab my silicone stranded core wire, which is also 22 gauge, but way more flexible, you know, like a noodle, so perfect for noodle feet. Gonna trim a couple of little pieces of this. Despite our focus issues, I'll just try and get as much of this as possible on camera, and I'll make sure to get something that can actually focus at this distance for future streams. All right. This silicone insulation, you can really just even almost pick off with your fingernails. It splits so easily. But it makes it great for, you know, any sort of a wearable project or anything where you need to be bending repeatedly. This stuff is just irreplaceable. So I think I'm going to solder into the battery holder first, and then we will go into the board. Might be a little bit tough to make that ground connection because we have so much other stuff connected there, but I think this one I'm going to connect to the bottom of the board as opposed to the top, so we won't need to be messing around with those components that we've been attaching to before. Here we go. Retwisting the wire. The other really nice thing about this wire, as opposed to, you know, normal PVC coated wire, is that because it's silicone, the insulation doesn't melt until it reaches like 200C or higher. So you have a little bit more time, you know, to get your connection right or whatever it is you're doing, without having to worry about your insulation just going to hell. Apologize for the coarse language, but it is what it is. There we go. Okay. A little bit of a better view for y'all. Okay. Number 1, our ground. And then our positive lead. Now, astute observers among you will notice that I have used 2 colors of wire for this whole project, and I've assigned them in non-standard ways. I'm using white and black wire, and those have those are not corresponding at all to power or ground or anything like that, which as a general rule is not really great. You want people to be able to easily look at your circuit and know what each connection sort of is, probably, have some sort of an indication of that. What you cannot see, or I guess you kind of can, but I am working out of what is more or less a college dorm room, and so I do not have the space to be stocking all the different kinds of wires. So I'm doing the best I can. I have 1 kind of solid core, 1 kind of stranded core, and I do my best to get along with that. There we go. Here is our other connection. Fantastic. We're now all soldered in on the battery holder. I have 1 little piece of the stranded core wire, 1 little strand that's flapping in the breeze there, so I'm just going to try and clip it so that it doesn't short out to anything. That's the sort of thing that could really cause a headache down the road. Probably never find it. All right. There we have it. All soldered together. Probably not the best move to solder this with the battery in place. We're just doing 2 connections, so it's not going to get super hot, but next time we'll not do that. Now, yeah, I mean, I guess, yeah, so by soldering this in, we're now going to be applying power to this project because we don't have a power switch, which is all right, but just something to sort of be aware of. I don't think it'll be a problem for programming or anything like that. And if it is, we can, just snip 1 of the connections and redo it when we're done. Have a little bit of difficulty fitting the wire into the hole here, so I'm just kind of twisting it. Okay. Looking good. Feeling good. Just gonna clamp this in first, then add the wire. One thing I'm really interested to see with this project is just how long this coin cell lasts. I know that on the baby noodle feet we see over here, little rigatoni, that coin cell, which is a bigger one, that's a 20 millimeter coin cell, has lasted for something like 8 or 10 hours at this point. And I have no idea what the battery life is supposed to be. I don't think anybody's really tested that yet, but it'd be nice if I don't have to be switching out this battery super frequently, if I could just leave it on, as sort of a display item on my desk or something like that. But we'll see. Okay, there's one connection. And just real quick, before I connect the second battery terminal, I'm just going to grab my multimeter and make sure that we don't have any shorts between power and ground, because I only have one of these batteries on hand right now. I don't want to be destroying it, so one moment. Just going to do a real quick continuity test. Here so you can actually see the multimeter. This will beep if we do have continuity. Oh, it's on voltage. Okay, so we'll test between 3 volts and ground. Nothing there. Between ground and ground to make sure that we're actually making a connection. Cool, so we have our ground. Ground is looking good. Power and ground. No connection, thank goodness. Awesome. Awesome. So, no short there. Red. Easy little test, but every once in a while it'll save you a battery, so I think it's probably worth it. A little bit of tea there. Straighten out our second wire, and we will solder it right on. I'm going to remove the battery, and then we'll solder in. Okay, safety folks among you, close your eyes. Shh, nothing happened. This isn't a knife. Put down your clipboard. Everything's okay. So battery's out. You may have noticed I did something you're not totally supposed to do. I just went right into the 3-volt supply, bypassing the 3-volt regulator because we have a 3-volt battery. Ideally, what you would want to do with something like this would be to go from a battery through some sort of a boost converter, like Adafruit has something called a power boost, which then goes from 3 or 3.7 volts, depending on what kind of battery you're using, to 5 volts, and then in through the onboard regulator on the trinket, so that you make sure you have a nice smooth power supply going to the microcontroller. But in this application, that would pretty much double the size of the project to add any sort of a boost converter. So it's totally fine for something like this just to go straight from the battery to your 3-volt rail, bypassing the onboard regulator. Okay. Also looks like we have a little bit of a dry solder joint here. So I'm just going to add a little bit more. There we go, back in view. Sweet. Then a ground connection. Actually, so I was just planning to go to the ground pin there, where we already have a ton of other stuff, but there's a little battery connector actually on the bottom of the trinket. It's meant so you can like solder in a JST connector. I think I'm going to go to that, just that we don't risk accidentally like desoldering any of our already onboard components, or already attached components rather. So I'm just going to apply some solder to that pad first, and then we'll just tack down the wire. Losing control. Okay. So we now have our battery holder firmly soldered in place. I'll show it to you real quick, and then we can add some electrical tape to make sure that we're not going to be shorting anything out between these two boards. Trim this down a little bit first. We have quite a bit of solder on there. So there you have the bottom of the board. Connect the batteries, or the battery. Looking good. And that will just sort of fold up like so, and as you can see, that wire is just ridiculously flexible. Might even end up hot gluing it once we have it, kind of hot gluing them together once we have this inside of a baby noodle foot, so we know that, like, the size is right and everything. For right now, I'll just leave it sort of flapping in the breeze like that, though. Now, moment of truth. We'll see whether this little guy will power up. All right. So we see, yep, we have a little blue LED going. The green light is on. And the sketch that I actually have loaded on this is what's having just that little blue LED be on. Normally when you get one of these brand new from Adafruit, it'll cycle through like a rainbow thing, because there's a little dot star, which is a RGB LED with like a little microcontroller in there, so it's addressable. But yeah, it's glowing. Very dimly, unfortunately. But it's also not set to 100% brightness, so we can make it brighter if we need to. Looks like it's kind of dying out. All right, so we'll need to see. So you can see that the little power LED on here is going gangbusters. So it may just be this dot star has a higher current draw or something. So we may need to turn that off entirely in order to power the LEDs and the speaker and everything, which isn't so bad, really. Battery is not heating up. I think we're okay. Cool. A little bit concerning, but not the worst. Also, absolute worst case, we can always use a different battery holder for this. So, maybe go up to one of those 20mm 3-volt batteries or something else. I'm just going to remove it for right now so we're not drawing current doing nothing. But yeah, there's our little hardware package. Just get these little arms out of the way, and we can take a look. How our little face. It is very derpy, but very cute. And when it's all up and glowing and blinking and chirping, it's going to be fantastic. So battery holder, 2 little LEDs, vibration sensor, So Noodle will be able to react to stuff, and then our little piezo element, so he'll be able to speak. And it all fits into a very tight little package if necessary. Definitely small enough to fit within the head, not of this one. Again, a recurring theme of this live stream is no lobotomies, but we will be able to put this brain into a very similar little baby Noodle feet, which will be just perfect. Before, Rigatoni over here was a little bit ambivalent, but I think he's starting to come around because this is very cool. Awesome. All right. So, with that out of the way, we'll check back in on our stream. We're at about an hour and 25 minutes. I think I might take a little bit of a break with one person watching who, at this point, I'm pretty sure is just me. If not, again, thank you very much. You're fantastic. But I think it probably is. So, I'm going to take a little break. Our hardware is done for the evening. We'll be moving on to a little bit of code. And I'll talk to y'all real soon. Bye. We're still very live.